This video covers arithmetic and geometric sequences, and our subject matter from QCAA is recognise and use the recursive definition of our arithmetic sequence, use the formula for an arithmetic sequence and recognise its linear nature, recognise and use a recursive definition of a geometric sequence, and use the formula for a geometric sequence. Now, all of this has been put in the one section, arithmetic and geometric, so you can see the difference between the two and identify whether you're dealing with an arithmetic or geometric sequence. And I recommend having your formula sheet with you when you're doing these questions, and you'll see sequences and series on there and see the formulas that are provided. Start with arithmetic sequences. An arithmetic sequence is a sequence in which each term differs from the previous one by the same fixed number, called the common difference. So, recursive definition of an arithmetic sequence is the next term is a previous term plus some value d, which is our common difference. So if you see the example here, we go 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14. So using that recursive definition, if we thought about it as being our third term is going to be equal to our second term plus d. So if we looked at this, our third term is 8, our second term is 5. So it'll be 5 plus our common difference is 3, so that would give us our 8. So that's our recursive definition. Now the general term, suppose the first term of an arithmetic sequence is a and the common difference is d. So that would mean our first term would be a, our next term would be a plus d. Our next term would be a plus d plus d. So if you go a plus d, which is a plus 2d. Then you would have a plus 2d plus d, which is a plus 3d, etc. So for an arithmetic sequence with first term a and common difference d, the general term with, or nth term, is t of n is equal to t of 1 plus n minus 1d. Now notice there the first term is, I've listed it as t of 1 instead of a, because that's what's given on your formula sheet. A lot of textbooks do use a for the first term though. Okay, so that's what I've put there. The first term is often denoted as a. So you can see that formula on your formula sheet. Now let's look at geometric sequences so we can see the contrasts in those. So instead of adding or subtracting a fixed number to get the next number in a sequence, we multiply or divide by a fixed number called the common ratio. So when we do this, we're creating a geometric sequence. So our recursive definition of an geometric sequence. So the recursive definition of a geometric sequence is t of n plus 1 equals r times t of n. Okay, so we've got an example here, 2, 10, 50, 250, 1250. So each time I'm multiplying by 5. So my common ratio is 5. T1 is 2, T2 is 10, T3 is 50. So our T3 equals whatever T2 is times by our common ratio, which is 5. So that'll be 10 times 5, which is 50. So you can see our recursive definition in the examples that I've put there. Now our general term, t of n, is geometric, so t of n plus 1 over t of n. So our second term divided by our first term. So if we look at this previous example, T3 is 50 and T2 is 10. So if we go 50 divided by 10, we get 5. So that will give us our common ratio for all positive integers n when r is constant. So that gives us our common ratio. Okay, so suppose the first term of a geometric sequence is a and the common ratio is r. So again, T1 equals a, so that's our first term. So T2 is going to be a times r, T3 is a times r squared, T4 is a times r cubed. We keep multiplying by our common ratio. So for a geometric sequence with first term a and common ratio r, the general term or the nth term is going to be t of n equals t of 1 r to the n minus 1. And remembering that your first term a is t of 1. Okay, look at your formula sheet for that formula. So let's look at some examples. Consider the sequence 2, 4, 6, 8, 10. State the formula for the general term t of n. So our first step is it arithmetic or is it geometric? So we need to decide, are we multiplying or are we adding? So if I go 4 minus 2, I get 2. If I go 6 minus 4, I get 2. If I get 8 minus 6, I get 2. So therefore it's arithmetic where my first term is equal to 2 and my common difference is also equal to 2. So my general formula is going to be Tn equals T1 plus, and if you look at your formula sheet, you'll see that it's n minus 1 times d. So T1 is 2 plus my n minus 1 times by 2. So it's going to be 2 plus, and we go 2 times n, 2 times negative 1. So 2 times n is 2n, 2 times negative 1 is negative 2, so it's going to be 2n. So that is my general term. So my fourth term would be 2 times 4 is 8, and you can check that. Calculate the 30th term of the sequence. So t of 30 is going to be 2 times by 30, which is 60. So therefore, 30th term is 60. Looking in the next one, for the sequence 2, 4, 8, 16, 32, state the formula for the general term t of n. Again, we have to see whether we're adding or subtracting. And you can see we can't add, so 2 to 4 is add 2, but 4 to 8 is an add 2. So this is when you go, okay, well 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. So therefore it's geometric. T1 is equal to 2 and my common ratio is 2. So T of n is going to be T of 1 and that's going to be multiplied by our r to the n minus 1. So T of 1 is 2 times by my common ratio of 2 to the n minus 1. Okay, so that's my general term. Calculate the 30th term. So T of n is 2 times 2 to the n minus 1. T of 30 is going to be 2 times 2 to the 30 minus 1, which is 2 times 2 to the 29. Go to your calculators. 2 times 2 to the power of 29, and it is a huge number. Okay, so that's your 30th term. Next one, if 41 is the nth term in a sequence, -4, -1, 2, 5, determine the value of n. Again, we need to know, is it arithmetic or is it geometric? Okay, so from getting from here to here, I could add 3. Here to here, add 3. Here to here, add 3. Okay, so therefore it's arithmetic. Our T1 is -4 and our common difference is 3. Okay, so that means T of n is equal to T of 1 plus n minus 1 times by d. It tells us that our nth term is 41. So 41 equals -4 plus n minus 1 times by 3. Add 4 to both sides. 45 equals n minus 1 times 3. Let's expand. 3 times n is 3n. 3 times -1 is -3. Get our numbers to one side. So 48 equals 3n, and then 48 divided by 3 is 16. So therefore, n is 16, I don't really need to write. Therefore, St. Mrs. just said the value of n. Now for the next one, for the sequence 36, 18, 9, the nth term is 9 over 16. Calculate the value of n. So we've got 36, 18, 9, and we keep on going. Okay, 36 divided by 18. I should go the second one divided by the first one, sorry. 18 divided by 36 is a half. 9 divided by 18 is a half. So it's geometric. Our T1, our first term, is 36, and our R is a half. Leave it as a fraction because it's told you the nth term is 9 over 16. So T of n is T of 1 times R to the n minus 1. We know that our nth term is 9 over 16, so 9 over 16 equals 36 times by my half to the power of n minus 1. Oops. Now I have to go 9 over 16 divided by 36 is 1 over 64. So 1 over 64 is a half to the power of n minus 1. So that means 64 has to equal 2 to the power of n minus 1. If we bring that 64 to be a power of 2, so we're using our prime numbers. I mean, you could use logs, but this is easier. 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. 1, 2, 3, 4, 5, 6. So 64 is 2 to the power of 6. So we've got 2 to the power of 6 is 2 to the power n minus 1. So n minus 1 equals 6. So n has to be 7. Okay, the 12th term of an arithmetic sequence is 9. So T of 12 equals 9. And the 25th term is 100. Calculate the first term and the common difference and hence calculate the 8th term. Pause the video, give this a go yourself. Okay, we know that our general term is A1 plus n minus 1d because it said it was an arithmetic sequence. Okay, so for T12, we're going to have T12 equals A1 plus 12 minus 1 times by d. 9 is going to be A1 plus 11d. Okay, and we have T25. T25 is going to equal A1 plus 25 minus 1 times by d. The 25th term is 100, so 100 equals A1 plus 24d. Equation 1, equation 2 that we need to solve. I'm going to subtract them because I can see that I have A1 in both. So if I subtract, I'm going to get rid of that. 100 minus 9 is 91. My A1's go. 24 minus 11 is going to be 13d. Divide both sides by 13. So d is going to be 91 divided by 13 is 7. So I've got my common difference. Sub d equals 7 into equation 1. So I'll get 9 equals A1 plus 11 times 7. 9 equals A1 plus 77. So A1 has to be 9 minus 77. 9 minus 77 is negative 68. Okay, I'm going to come up here. So we've got A1 is negative 68. And we've got D equals 7. It asked for the 8th term. So T of n equals A1 plus n minus 1d. T of 8 is going to be negative 68 plus 8 minus 1 times by 7. Negative 68 plus 7 times 7. Negative 68 plus 49. Negative 68 plus 49 equals negative 19. So therefore, 8th term is negative 19. Next one, the 3rd term of a geometric sequence is 10 and the 6th term is 80. Pause the video, give this a go yourself. Okay, so T of 3 equals 10, T of 6 equals 80, and we know our formula is T1 times R to the n minus 1. So for T3 we're going to have 10 equals T1 times r to the 3 minus 1. 10 equals T1 r squared. For T6, we're going to have 80 equals T1 times r to the 6 minus 1. 80 equals T1 r to the 5. Equation 1, equation 2. Now to get rid of something here, you divide. So if you go 2 divided by 1, you're going to have 80 divided by 10 equals T1 r to the 5 divided by T1 r squared. And you'll see the r's cancel. Okay? So now 80 divided by 10 is 8. R to the 5 divided by r squared is r cubed. To get what r is, put both sides to the third, which is the same as cubed rooting both sides. So my r is equal to 2. Sub in equation 1, and I'm going to have 10 equals T1 times 2 squared. 10 equals 4T1, so T1 equals 10 over 4, which is 5 over 2. Come up here. Therefore, I have T1 equals 5 over 2, and I have my R equals 2. And I am done because that's all it's asked for. Next one, a national park has a series of huts along one of its mountain trails. The first hut is 5 kilometres from the start of the trail. The second is 8 kilometres from the start. The third is 11 kilometres, and so on. Calculate how far the start of the trail is from the 6th hut. Calculate the distance between the 6th hut and the 12th hut. You can do that on your own, and you can check the annotated slides for the solution. Same for this one. Calculate the number of terms for the sequence 27, 23, 19, 15, all the way to negative 33. Give it a go. Check my slides for the solution. Now I will go through this one. A bouncy ball is dropped from a height of 10 metres. It rebounds to 4/5 of the original height. Calculate the height the ball rebounds to after 10 bounces. So what is happening is we've got this bouncy ball and it's been dropped, okay, where this is 10 metres. So bouncy ball is dropped from a height of 10 metres and then it rebounds to 4/5 of its original height. So times by 4 over 5. So if you go 10 times 4 over 5, you will get 8. And then it's going to rebound again by 4 over 5. So if you times by 4 over 5, you get 6.4. So you can see what's happening. This ball just keeps rebounding. Okay? So the key is to know what turn you want. It says calculate the height of the ball after 8 bounces. Okay? So this would be original. This is after bounce. So this is bounce, whoops. This is bounce 1. This is bounce 2. So this is T1, T2, T3. So you should be able to see that after 8 bounces, I want T9. So bounce 8, I want what T9 is going to be. And that's the trick. Don't think you want T8. Okay? So always be careful about these kind of questions. So we know that T1 equals 10, and we know my R is 4 over 5. We also know it's geometric. So Tn is T1 times R to the n minus 1. And I want the 9th one, so it's going to be 10 times 4 over 5 to the 9 minus 1. Okay, so that equals 10 times 4 over 5 to the power of 8. And we go to our calculator, that's approximately 1.68. So therefore, ball bounces to a height of approximately 1.68 metres after 8 bounces. Okay, so be careful of those kind of questions. And then there's another one that you can try again. You can refer to my slides for the solution to that. There's quite a number of exercises, quite a number of questions, because we have combined arithmetic and geometric, whereas in the textbook they're separate. So work your way through those exercises.